Good day to everyone. Today's lesson is going to be our introduction to circles and to talk about slope a little bit. So this entire chapter is about lines and parallel lines within a plane. And so in order to do that, we need a little bit of pre-knowledge. So first of all, parts of a circle. The diameter is the one that goes through the middle and goes all the way across. Okay. The spot in the middle is the center, and the radius is the one that starts at the center and goes to a point on the circle. And then their circumference is the one that goes all the way around. So kind of what you guys like to think of as perimeter. A segment that connects any 2 points on a circle and passes through the center is known as the diameter, as you can see from the picture up here. Passes through the center and then connects any 2 points on the circle. A segment from the center of a circle to any point on the circle, we kind of already said that, that's the radius. The perimeter, distance around, also said that, circumference. Okay. Half of the diameter is the radius, and then going the opposite direction, twice as long as the radius is the diameter. Okay. All right, the formula for the area of a circle is A equals pi r squared, and the formula for circumference is 2 pi r. So to help us remember circumference, we have a little song. It goes, twinkle, twinkle, little star, the circumference equals 2 pi r. So a little way to remember it, little fun way. And then what is the relationship between the diameter of a circle and the radius of the circle? And we kind of already said this up here. So I'm just going to draw an arrow down. So half of the diameter is the radius, and twice as long as the radius is the diameter. Okay. Let's go to the next page. So how would you define a circle? You define a circle by its center. Okay, so this part right here. So we would say, and this is how you draw a circle, and then in this case, it is circle O. So I kind of made it really big, but usually you make it a little bit smaller, and then the capital letter in the middle. So to name the circle, again, we look for the center, and we draw the little circle with a center in the middle, and that's going to be circle P. And actually, sorry, I was looking for the eraser. Let's go ahead and make that right next to it. Okay? And then a radius is a segment, so we have to use a segment symbol. And by the way, radii is plural for radius. So we actually have 3 radii listed. We have PA, PB, and PC. So one thing that's good to note about circles is that all radii of a circle are congruent. Think about why. So if the definition of a radius is that it starts at the center and goes to a point on the circle, then that would be the same measure every single time. All right, so we have a little proof here. And it says given circle P, so that means that given circle P, we know that all the radii are congruent, okay? But we can't mark that yet. That's going to be part of our proof. So let's go ahead and mark the given. And we're trying to prove AB is congruent to CD. So first of all, again, we're going to bring in last chapter about congruent triangles. So notice that there are 2 triangles in here. So if we're trying to prove AB is congruent to CD, then we should probably prove the triangle's congruent so that we can say CPCTC. Well, we know that PC is congruent to PB and AP is congruent to DP. Why? Because these are all radii, and all radii are congruent. So PC is congruent to PB, and PD is congruent to PA. Now, technically all four of these are congruent, but I set it up so that I have two pairs so that I can use a congruence postulate to prove them congruent. The triangle's congruent. So all radii of a circle are congruent. And yes, you need to write this one out. Okay. And then we don't have anything else from the given, so we need to look at the diagram. Is there anything from the diagram that I can get? I can. I have vertical angles congruent. So angle CPD is congruent to angle APB. And the reason being is vertical angles are congruent. So how did I know these were vertical angles? Remember that vertical angles are created by intersecting lines. It forms the V. So I have vertical angles congruent. Well, hopefully now, if you mark your diagram, you see we have SAS. So triangle CPD is congruent to triangle APB by SAS. And now, since we proved triangles congruent, corresponding parts are congruent, so we can say AB is congruent to CD by CPCTC. Okay? Again, remember that in order to use SAS, the angle must be between the two sides. Well, here's the side, and notice that the angle is in between. All right, next slide. So that actually concludes our introduction into circles. And now we're going to talk, we're not doing this the whole lesson, so if you look in 4.2 in your notes, it's longer than this. We're not doing all of that. What we're going to do is we're just going to talk about slope today. Okay. So first of all, remember that slope is the change in y over the change in x. So change in y over change in x. So y2 minus y1 over x2 minus x1. Remember that you can also flip that order, but remember if you flip the order, you have to do it on both top and bottom. Okay? So visualizing slope, remember that if we rise to the right, okay, then this is a positive slope. If you remember last year in class, we did those little exercises where we stood up. This is a negative slope. I fall to the right. I'm going the negative direction down a ski hill. This is a constant, so that's going to be 0. And then, we crashed. That's going to be undefined. Or remember that last year we did when 0 is underneath, it's underfined. Get it? No. Okay. So the first thing we're going to do is we're just going to practice finding the slope. So y2 minus y1 over x2 minus x1. So 5 minus 3 over 6 minus negative 2. Be careful with negatives. Make sure that you use parentheses around them. So this gives me 2 over 8, which simplifies to 1/4. And yes, you should simplify your fractions. Okay, and then the next one, same thing, just y2 minus y1 over x2 minus x1, so negative 14 over 0. Remember when 0 is underneath, it's undefined. Oh shoot, I actually wrote it. Undefined. Make sure you actually write undefined and not underfined. I was thinking about saying it and then I actually did it. Okay, and then looking at the graph. So this is a constant. Remember Hoy. So if it's horizontal, the slope is 0 and it's a y equals equation. And then up here, this one that we just did would be a VUX situation. So vertical, undefined, and x equals. And I'm going to go ahead and zoom in on this graph. Okay, so we're looking in for the change in y over the change in x. So first, let's find 2 points where it crosses evenly. And we do the change in y over the change in x. So I went down 4, so that's -4. And then I went to the right, a +1. So the change in y over the change in x, so -4. Make sure you put the y above. So change in y over change in x. Okay, and then the next thing we're going to talk about is slopes and parallel and perpendicular slopes. So parallel lines are going to become really important later on in this chapter. So remember that if lines are parallel and they're two non-vertical lines, this happens if and only if they have the same slope. Okay, that would make sense because we would be rising and running at the same rate. Okay, let's go ahead and go to the next page. So it asks us to find if these two lines are parallel or not. So in order for them to be parallel, this needs to be the same slope. So we're going to plug in. So we have y2 minus y1, careful of negatives again, x2 minus x1. So that gives me 7/9. So my slope on the next problem must be 7/9 in order for these to be parallel lines. So -5 minus 2 over 3 minus 4, so -7 over -1, which gives me 7. So these would not be considered parallel because they do not have the same slope. Okay, so in order for it to be parallel, we need to be the same slope, the same rise over the same run. Now for perpendicular lines, okay, they can only be perpendicular if and only if they have opposite reciprocals. Make sure that you do both parts. So sometimes we just do the opposite and sometimes we just do the reciprocal. You must do both, opposite reciprocals. Okay. So it says find the altitude of AC. Remember that the altitude starts from the vertex of a triangle and goes to the opposite side and creates a 90-degree angle. It makes it perpendicular. So if I want to find the slope of the altitude, I need to find the slope of this line because it needs to be perpendicular to BE. So perpendicular to BE. So if I find the slope of BE, then I can do the opposite reciprocal to find the slope of the altitude. And let's go ahead and mark this C so that we see it visually on our diagram. All right, so the slope of segment BE is going to be 5 minus 3 over 6 minus a -4. So that gives me 2/10, which is 1/5. So then the slope of AC, which is the altitude, needs to be the opposite reciprocal of the slope I just found. So opposite means change the sign, so that'd be negative, and then reciprocal means flip it, so -5. So make sure that with perpendicular lines or slopes that you do opposite reciprocals. Okay. All right, the next example says find the slope of the median. So the slope of the median, first of all, the median starts from the vertex of a triangle, goes to the opposite side, and splits this into two congruent parts. It meets it at the midpoint. Okay, and we're going to go ahead and label that AD. So I need to find the slope of this line. I know one ordered pair, it's negative 210, but I need to figure out this ordered pair. Well, if you thought about the definition of a median, which is that it starts at the vertex and goes to the midpoint of the opposite side, that means that this is the midpoint of segment BE. So that means I can find the ordered pairs. So the midpoint of BE is going to be negative 4 plus 6 divided by 2 and 3 plus 5 divided by 2. Remember that when you're finding the midpoint, you want to do the average. Well, average is addition. So this is 2 over 2, 8 over 2, so that gives me 1/4. So now I can find the slope of this because I have an ordered pair up here and I have an ordered pair down here. So the slope of AD is going to be 4 minus 10 over 1 minus a negative 2. So that gives me negative 6 over 3. So my slope is negative 2 of the median. Okay. All right, and then we are going to leave example 2 for class. As always, thanks for tuning in.